Couple of homework. Here's your guys' homework number 3. Factoring trinomials a is equal to 1. So just going to show you guys a couple of examples so that you guys have some modeling so that, you guys can be successful in achieving to finish up this homework. So a lot of these problems are pretty much factoring trinomials when a is equal to 1, but some of them have GCF as well, so we'll go over a few. So if we go over like a problem like number 1, we got coefficients of 1, coefficient of 8, and a coefficient of 7. Remember, when you guys do your x method, right, you have to look at, okay, well, the top is a times c, or the first coefficient times the third coefficient, which is 1 times 7, so that's going to be 7. And on the bottom, you guys are going to have your b value, or the second coefficient, which is 8. So now you have to ask yourself that question, right? What two numbers multiplied together will give you 7, but when you add them together, it will give you 8. So we could make factors of the 7, and the only option we have is 1 and 7, which is perfect because 1 times 7 is 7, but then 1 plus 7 will give you 8. So this is correct, and then that means our factors are going to be b plus 1 and b plus 7, and there is our two factors. So I'll just go over a couple of these examples so that you guys get a better grasp of it. Let's try number 7 then. So for number 7, right, your first coefficient, your a1, is coefficient of 1. Your second coefficient, your b value, is 2. And your third coefficient, your c value, is negative 24. Now when you guys do your x method, right, a times c, or your first coefficient times the third coefficient, that's negative 24. And your b value, or your second coefficient, we're going to put at the bottom. So we have to think, right, what factors of negative 24 are there where if we multiply two numbers, it'll give us negative 24, but when we add it, it gives you 2. So you could write all the factors of 24, right? So 1 times 24, 24, 2 times 12, 24, 3 times 8, 24, and 4 times 6 is 24. So which one of these, if we add them together, it would go to the bottom? The only one is, it would be this one. So we know it's going to be 4 and 6, but one of these has to be negative. So it has to be full. The 4 has to be negative because negative 4, although negative 4 times 6 is negative 24, negative 4 plus 6 is going to give us the positive 2. So there's the combo. So then our factors are m minus 4 times m plus 6. And those are our two factors. So a couple of those that you guys are just going to have to do. Now let's go to one where we have to factor out a GCF. So let's look at like number 15. So for number 15, right, before we start factoring the trinomial, look, there's 2, 6, and negative 108. So we can factor out what is a common number that can go into all of these, and it's 2. So we can factor out a 2 from each one, but remember when we factor out a 2, we're really dividing each number by 2. So 2 divided by 2 is 1, so just n squared. 6 divided by 2 is 3, and 108 divided by 2 is negative 54. So now we can label our coefficients. A is equal to 1, B is equal to 3, C is equal to negative 54. And now we can do x method, right? What two things multiplied together will give you negative 54? Well, when we add them, gives you 3, right? So you could write all the factors of negative 54 to help assist you. 2 times 27, 3 times 18, 4 can, 5 can, 6 can, 6 and 9. So which combination of these, if we add them together, could possibly, or subtract them from each other, will possibly give us 3? And it's this one, right? 6 and 9, but which one has to be negative? The 6, because negative 6 plus 9 will give us a positive 3. If it was vice versa, then this would give us negative 3, which is incorrect. So it has to be this. So don't forget when you factored out the GCS, we still need that. So we have n minus 6 and n plus 9 as our factors. And as a result, these couple problems should aid you in order for you guys to do the rest. So good luck. Hopefully this helped you guys, and if you have questions, please let me know. Okay, good luck everybody.